A hybrid solar inverter system is a smart way to keep your home powered, even during a blackout. With this system, you can use both solar energy and stored battery power. That means your lights and appliances stay on, even when the grid goes down. It's kind of like having your own mini power plant at home. Energy independence is another big benefit. When you install a hybrid system, you produce your own electricity, you use less from the grid and save money over time. It's also good for the environment because you use clean solar energy. Many households worry about power outages. Storms, accidents, or grid failures can leave you in the dark. A hybrid system gives you peace of mind. Your fridge, lights, and essential devices will keep working. By choosing a hybrid solar inverter system, you take control of your power. You make your home safer and more comfortable. You also help the planet by using renewable energy. A hybrid solar system uses solar panels, an inverter, and batteries. The solar panels collect energy from the sun. The inverter changes this energy into power your home can use. The batteries store extra energy for times when the sun is not shining. When the sun is out, your solar panels create electricity. This power goes to your home first. If there is extra, the system stores it in the batteries. If your batteries are full, extra power can go back to the grid. This helps you get credit on your electric bill. When the grid goes down or at night, the batteries take over. The system sends stored power to your essential appliances. The automatic transfer switch makes this change happen fast. You might not even notice the power went out. A hybrid system works quietly in the background. It manages solar, grid, and battery power automatically. You get steady electricity, day or night. Setting up a 10-kilowatt hybrid solar inverter system is a significant investment, and having the right equipment is crucial for both safety and performance. Before you begin, make sure you have a clear understanding of each component and its role in the system. Always choose equipment that matches in size, voltage, and capacity. This ensures that all parts work together seamlessly, preventing issues down the line. Using the correct ratings not only keeps your system safe, but also maximizes efficiency and extends the lifespan of your investment. Here's a detailed checklist of what you'll need for a $10 hybrid system. First, solar panels. You'll need about 20 to 25 high-quality panels, each rated between 400 and 500 watts. The total wattage should add up to at least 10 kilowatts. Consider panels with high efficiency and a solid warranty, as they'll perform better over time and withstand harsh weather. Second, a hybrid solar inverter. This is the heart of your system. Choose a single 10-kilowatt inverter designed for both grid connection and battery backup. Make sure it's compatible with your local grid voltage and frequency, and supports the type of batteries you plan to use. Third, a battery bank. You'll need lithium or deep-cycle batteries with enough storage to meet your needs. For a 10-kilowatt system, plan for at least 10 to 20 kilowatt-hours of battery capacity, depending on how much backup power you want. More capacity means longer backup during outages. Fourth, mounting racks and rails. These must be strong, weatherproof, and suitable for your roof type or ground installation. Proper mounting hardware ensures your panels stay secure and optimally angled for sunlight. Fifth, cables and connectors. Use wires specifically rated for solar applications. You'll need enough cable for both direct current from the panels and batteries, and alternating current to your home's electrical system. Quality connectors reduce energy loss and improve safety. Sixth, an automatic transfer switch. This device automatically switches your power source between the grid, solar, and batteries during outages, ensuring a seamless supply of electricity. Seventh, breakers, fuses, and disconnect switches. These safety devices protect your system from electrical faults, overloads, and short circuits. Install them at key points for maximum protection. Eighth, a monitoring system. While optional, a good monitoring system lets you track your system's health, energy production, and usage in real time. This helps you spot issues early and optimize performance. Always double-check that all parts are compatible. Look for matching voltage, current, and communication protocols between components. Compatibility is key to a reliable and efficient system. If you're unsure about any part of the process, don't hesitate to consult your supplier or a certified solar professional. Their expertise can help you avoid costly mistakes and ensure your system is set up for long-term success. Begin by choosing where to put the solar panels. The roof is common, but ground mounts work too. Pick a spot with plenty of sun and no shade. Make sure the surface is strong enough to hold the weight. Install the mounting racks first. Follow the manufacturer's instructions. Use stainless steel or aluminum hardware to prevent rust. Attach the racks securely to the roof beams or ground anchors. Next, attach the solar panels to the racks. Secure each panel with the proper clamps. Double check that every panel is tight and cannot move or shift. Position the panels so they face the sun for most of the day. Connect the panels together using MC4 connectors or what the manufacturer recommends. Wire panels in series or parallel, based on your inverter's needs. Run the cables carefully to your inverter location. Use weatherproof conduit to protect the wires. When setting up your battery bank, one of the first things to consider is where you'll place it. Ideally, you want to choose a cool, dry location indoors, such as a dedicated utility room or a well-ventilated storage area inside your home. This helps keep your batteries in a stable environment, away from temperature extremes that can affect their performance and lifespan. It's really important to avoid areas that get direct sunlight or are prone to dampness, like basements that might flood or garages that heat up in the summer. Excessive heat, moisture, or sunlight can dramatically shorten your battery's life and even cause safety issues, so always pick a spot that stays dry and shaded throughout the year. Place your batteries on a sturdy, non-metallic rack or shelf. Make sure there's enough space between each battery to allow for proper airflow. This helps prevent overheating and makes maintenance easier. Good airflow is essential for keeping your battery bank running efficiently and safely. Next, it's crucial to install a breaker or fuse between your batteries and the inverter. This safety device protects your system from short circuits or electrical overloads, which could otherwise damage your equipment or even start a fire. Never skip this step. It's a key part of any safe battery installation. When connecting your batteries, always use wires that are thick enough to safely handle the amount of current your system will draw. Check your battery manual or consult a professional to determine the correct wire gauge. Using undersized wires can lead to overheating and energy loss. If you're connecting multiple batteries, use the proper cables and follow the manufacturer's instructions for series or parallel wiring. Series wiring increases voltage, while parallel wiring increases capacity. So make sure you wire them according to your system's needs for optimal performance. After connecting everything, tighten all the terminal connections securely with a wrench. Loose connections can cause sparks, heat buildup, or even system failure, so double check for any loose wires or signs of arcing before moving on. Once your connections are secure, cover all battery terminals with plastic caps or insulation to prevent accidental contact. It's also a good idea to label each cable clearly. This makes future maintenance safer and much easier to manage. Finally, if your system supports it, install a battery monitor nearby. This handy device lets you keep an eye on your battery's health, charge levels, and overall performance over time, helping you catch any issues early and get the most out of your battery bank. Alright, let's get started with mounting and connecting the hybrid inverter. This is a crucial step in setting up your solar power system, as the inverter acts as the heart of your energy conversion process, managing the flow of electricity between your solar panels, batteries, and your home's electrical grid. First, carefully select a location to mount the hybrid inverter. Ideally, it should be on a sturdy wall near the battery bank and your main power supply. This minimizes cable lengths, which helps reduce energy loss, and keeps your installation neat and efficient. It's important to choose a spot with good ventilation, and make sure it's away from any heat and moisture. Proper airflow helps prevent overheating, which can affect the inverter's performance and lifespan. Avoid areas exposed to direct sunlight or dampness. Use strong bolts to hold the inverter firmly in place. Make sure the mounting surface is solid and level, as a secure installation reduces vibration and potential damage over time. Next, connect the DC cables from your solar panels and batteries to the inverter. These cables carry the electricity generated by your solar panels and stored in your batteries, so double-check that you're using the correct gauge and type of wire for safety and efficiency. Be sure to follow the manufacturer's wiring diagram closely, and, make sure all connections are tight and secure. Loose connections can cause overheating or even system failure, so take your time and double-check each step. Double-check the polarity. Positive to positive, negative to negative. Incorrect polarity can damage your inverter or other components, so always confirm before tightening the terminals. Now, connect the inverter to your main electrical panel. This step allows your home to use the electricity generated by your solar system, and also enables excess power to be sent back to the grid if your system supports it. Use the correct AC cables and follow all safety steps. Always turn off the main power before making these connections, and if you're unsure, consult a licensed electrician to ensure everything is up to code. Some inverters require you to enter settings for grid voltage and frequency, so enter these exactly as shown in the instructions. Accurate settings help your system operate safely and efficiently, and prevent compatibility issues with your local grid. Once everything's connected, test the inverter by turning it on. Listen for any unusual sounds and check that the startup sequence completes smoothly. Watch for any warning lights or error messages. If you see any, refer to the troubleshooting section of your manual to resolve them before proceeding. If all looks good and the system is running smoothly, congratulations! You've successfully mounted and connected your hybrid inverter, and you're ready for the next step in your solar installation journey. The automatic transfer switch, or ATS, lets your system switch from grid to battery power during outages. Mount the ATS close to your main panel and inverter, and use screws or brackets for a solid fit. Connect the ATS to the inverter, the grid, and the panel that supplies your essential loads. Make sure to use wires rated for the proper voltage and current, and label all connections clearly to avoid mistakes. When wiring, always follow the diagram from the ATS manufacturer. It's really important to make sure essential circuits, like lights, your fridge, and outlets, are connected to the backup side. This ensures only important loads use battery power during outages. To test the ATS, turn off the grid power at your breaker. The system should switch to battery power in just a few seconds. Then, turn the grid back on and watch it switch back. If everything works smoothly, your backup is ready. Grounding is super important for electrical safety. It protects both you and your equipment from shocks and surges. Always use thick green wires for grounding. Connect all metal frames, racks, and the inverter to a ground rod in the earth. Be sure to follow your local electrical codes. Since many places require permits and inspections, only use certified parts and tools. Never skip safety steps, even if you're in a hurry. And remember, always wear safety gear like gloves and goggles when working with wires. Never touch live wires. If you're unsure about any step, call a licensed electrician. Safety always comes first. Before turning on the system, check all connections. A good ground keeps your family and your home safe from harm. Now it's time to test the whole system. Turn on the inverter and check if your solar panels are making power. The display should show how much energy you're getting from the sun. Check the battery monitor as well, and make sure the batteries are charging when the sun is out. If the grid goes out, use the ATS test button or just turn off the main breaker. Your essential loads should keep working from battery power. Watch for any warning lights, error codes, or strange noises. If you see a problem, turn off the system and check all connections. Most issues come from loose wires or wrong settings, so read the manuals for simple fixes. After testing, your 10 kilowatt hybrid solar inverter system is ready to use. Just remember to clean the panels now and then and check the batteries every few months. Enjoy clean, steady power at home, no matter what happens outside.